Hello, in this video I'm going to do a derivation of derivation 266, which is the derivation that enables a very important rule, one version of De Morgan's. So this is a derivation that you're going to need to do for homework. It's tricky, and so what you're going to want to do is follow along and do it as I do it. So you might want to pause the video right now and open up a derivation module. I will be here when you get back. Okay. I hope you're back with the derivation module open, so let's go ahead and proceed. So first thing is always show conclusion. Now we look at the conclusion. This is a theorem, there are no premises. We look at the conclusion and we see it's a biconditional. So how are we going to get a biconditional? Well, the rule we have for getting biconditionals is CB, and it says if you have the conditionals going in both directions, you can put them together to form the biconditional. So what we want to do is get the conditional going in both directions here. So, okay, what is that going to be? Well, it's going to look like this. So we're going to have this one. So we're going to want to get that. And then we're going to want to get the conditional going in the other direction, which is going to be like this. Okay? And once we get these two, we're going to put them together with CB. And that's going to give us the conclusion. And that means that we have a direct derivation. Now, the easiest way for you to enter this into the program is to do this. You're going to say show and then cond for show conditional. And it's going to, you use show cond when you have a biconditional and you want to show the two component conditionals. So we'll do first the left to right conditional, and then we'll do the right to left conditional. So let's look at this one. Okay, so this is a conditional we're now trying to show. So we'll go ahead and say assume CD. Good. Now, it would be good to show the consequent. Okay, so we want to show not P and not Q. Now, how are we going to do that? How are we going to show not P and not Q? Well, what we want to do is we're going to want to show not P, and then we're going to want to show not Q. And once we have those two, we'll be able to put them together. We'll be able to adjoin them, and we'll have not P and not Q. So we're going to do two subsidiary subderivations. And again, we have some nice show commands. This time we can say show conj for show conjunct. So which conjunct? Let's show not P first. Okay, so we're going to show not P, and then we're going to show not Q separately, and then we're going to put them together, which is going to give us not P and not Q. That's what we want to then work up the closing up the subderivations. Good. So what should we do here? Well, whenever we enter when we have a show line and we're not going off on some show strategy, we should make an assumption. So let's make an assumption. Can we make a conditional assumption? No, because we're not trying to show a conditional at this point. We're trying to show negation P. So we should instead say assume ID, and we have P. So now what are we going to do? Well, we just made an indirect assumption, and that means we're likely to box and cancel with indirect derivation. And how do we box and cancel with indirect derivation? We get a sentence and its negation. So we want to look and see, well, do we have what sentences do we have? What negations do we have? So we have P on line 6. So if we also had not P, we could say ID. So not P would be nice to get. But we're already trying to show not P, so that might not be so helpful. Now if we look on line 3, we see we have a negated disjunction. We have not P or Q. Well, if we could get P or Q, then we would have what we need for a indirect derivation, because we'd have P or Q, and then we have not P or Q, and that's contradiction, and that's what we need to do ID. Okay, good. So if we can get P or Q, we're done. Well, can we get P or Q? In fact, we can, because we have P on line 6, and so we can apply our addition rule. Addition says if you have a sentence, you can put it in a disjunction with whatever other sentence you want. So we're going to say 6 addition, and we want to choose this one. We're going to replace the Z with a Q. So we're going to put in Q, and there we have P or Q. And so now we could say 37 ID. Oh, no, 3 is not within the current subderivation. So what do we have to do? We have to move 3 down. So we'll say 3R. We're going to use R, that rule we just learned. And now we have R here. And now we can say 78 ID. And we have an indirect derivation, because P or Q contradicts not P or Q. So we've shown not P. Okay, I'll leave that open. If you want to see that, you can pause the video now, but I'm going to go ahead and close it. Now, we're trying to show not P and not Q, and we've just shown not P. When you finish a subderivation, if you can, you want to use the thing you've just subderived right away, but we can't use not P yet. First, we need to get not Q, and then we'll put them together. Okay, so let's show not Q. And we could have written show conj here. We could have said, again, show conj, and this time we would select not Q. Good. So now we have not Q. We'll go ahead and make an indirect assumption that gives us Q. And we're just going to do the same thing we did in the previous derivation. We have Q. We want to get P or Q to contradict line 3. So this time we're going to add P, but we're going to add it on the left. So we're going to choose the first version with the Z on the left. And then we will put the P, we'll place the Z with P, and we have P or Q. Again, we'll repeat 3, and we have another indirect derivation. So I'm going to go ahead and close this. If you want to watch it, go ahead and pause it. So now we're going to put 5 and 10 together because they're the two pieces of 4. So we'll say 5 and 10, and this time we'll use the rule not add, but the rule ADJ adjoin, which is the rule that forms not disjunctions but conjunctions, and we have not P and not Q. Okay, that's nice. That's the same thing as line 4, so we have a direct derivation of line 4. Good. And line 4 is what? Line 4 is the consequent of line 2. So we have a conditional derivation of line 2. Right? 4 is the consequent of 2. Good. Are we done? No. Why not? We have to show the conditional going in the other direction. Line 1 is a biconditional. We've shown one of the two conditionals that are part of it. Now we need to show the other one. So again, you can pause this, but I'm going to close 2. And we're going to enter our show conditional shortcut again. Okay, so we've already shown this one, so now we want to show this one, the conditional going in the other direction. So we'll say okay. So now we're going to show if it's not the case that P and it's not the case that Q, then it's not the case that P or Q. Okay, so we're trying to show a conditional, so we'll make a conditional assumption. And it'll be good to go ahead and show the consequent. Okay, now here we're trying to show a negation. We're trying to show not P or Q. So what should we do? We should make an indirect assumption, because when we do, we can take away the negation and we have P or Q, and that's quite useful. Okay, why is it useful? Well, look at 19. We can say, we can get not P out of 19, and then we can do MTP with our previous two lines, and we get Q. And hey, that contradicts the right-hand side of 19, so let's bring that down, and we have a contradiction. 23, 24 ID, good. 20 is the consequent, let's close this up. 20 is the consequent of line 18, so that's another conditional derivation. Let's close this up, and now we can say, let's put these two conditionals together with CB, minus 2 minus 1 CB, and there's our direct derivation. So I'll just pop that open again if you want to be able to see that, and you can pause it. It's pretty big, so there's the first part, and there's the second part. Okay, so you're going to want to do this derivation. Why? Because it's going to enable one of the DM-derived rules. It's going to enable the rule in particular. It's going to say when you have the negation of a disjunction, what can you do with that? You can turn it into a conjunction of negations, and you can apply S to that conjunction, and that's really useful. So this theorem derives a super useful rule, a rule that you'll actually be using all the time once you derive it, and it will make your derivations easier. So that's the end of this video. I'm going to have one more video on derivations in this unit where I'm going to talk about some sort of overall derivation strategies. So, good deriving.